before we talk about scalability is kind of like this buzzword that we throw around a lot. So I just wanted to make sure we all understood what we're going to talk about in our talk before we dive in. So what do all scalable systems have? Obviously, scalability is part of it. And that's just being able to handle a high amount of requests from users, and also being able to meet a growing demand of users as well, so over time. Then there's high availability, making sure that our systems are stable, so that way we can always be handling these requests from the users. So as many nines as possible in terms of uptime. And then finally, maintainability, making sure that our systems are reasonable in terms of the amount of resources it takes to keep them running. So we're going to cover how do we scale data, what do we do when something goes wrong, so fault tolerance, and then finally scaling your model. And I'm Mike from Looker, Mike Xu. I'm an architect, and I'll be covering the scaling your data. So when you're architecting your data stack, there's some key characteristics you want to make sure you understand that you need before you actually pick your tools, whether it's your database or your ETL. And I like to split them up through these 4 different pieces, which is how real time is our use case. How real time do we want our data to be? Then we want to know how fast do we want these systems to be? Do we need our queries back in a second, or is like a minute reasonable? Then we want to understand the concurrency. How many users are we going to have running live queries against the database at once? And then finally, there's price. You can have all 3 characteristics maxed out, but then it's also going to be very expensive. It may exceed your budget. Another component that may matter to you is whether or not you can even use a cloud offering. So some of these ETL tools and databases, they're SaaS only, and maybe that's not an option for your security requirements. So picking a database, I split all the databases that we work with in these 5 different families. The first family is like a transactional replica. This is like the easy bake oven version of a data warehouse. You just spin up a replica against a read performant database, and you're good to go. These are very difficult to scale over time. It can be done, but it requires a lot of work and tuning. Then we have our columnar data stores. These are the MPP family of databases. They're designed for read performance, and they're pretty good for the price you pay for them. So they're a great next step after you move out of your replica. Then we have the in-memory databases. So these perform their operations in memory or against SSD drives, which is really fast and really great for real time, but they can be very cost prohibitive because obviously memory is more expensive than disk. Then we do have the HTFS SQL. So all the Hadoop family versions of SQL, if you're storing huge data lakes, we want to query against them. There's a bunch of technologies for that. And finally, there's not a really great word for this, but we call it the separated storage and compute data warehouses. So these are the cloud offerings that sort of blend the columnar architecture and also the distributed file system architecture together to make sure that when you're running your queries, you're getting a lot of compute resources, but only when you need it for your queries. So you can kind of imagine these sort of as a timeshare for like a really great mansion or something, and only when you need to run your queries do you have access to that mansion. And this is sort of like where we see a lot of cloud architectures moving towards. Once you picked your database, you're going to want to make sure it's optimized. So there's a couple things to like avoid, such as like joins if you're using a columnar heavy database or like some kind of interesting indexing strategy database. You're going to want to reduce node-to-node communication, and all node-to-node communication is just on the aggregate level. You also want to transform your data ahead of time if you know what form it needs to be in. And then finally, you can optimize like the configurations of your database or those queries at runtime, which is typically the hardest thing to optimize. There's also optimization we can do that I call like the dark side of optimization, which is like how do we reduce those expensive, unscalable tasks, right? So like we can let go of real-time usage. Like we could also aggregate our data sets. So we can't drill back to the detail level, but we have very fast reporting. You could also aggressively cache and pre-warm this cache. And finally, you can create priority queues, right? Like maybe your CEO should always cut to the head of the line on the database, and all their dashboards should load in like 1 to 3 seconds. But then maybe all your analysts can survive like 1 minute long dashboards. Yeah. That's what we do. And then there's architecting your ETL. So the thing with ETL is like this is definitely where you're going to get a lot of spaghetti code. And that's just the nature of ETL. Like we're constantly adding new data sources, and those data sources are constantly changing depending on the offerings we pick. Like we use Salesforce, and our data is constantly shifting. It's very dynamic. So there's some things to think about when you pick your solution. There's 2 strategies for creating your ETL. You can buy something off the shelf, or you can build it yourself. So if you're buying something off the shelf, the key thing to think about is, does it provide all of the connectors you need for all those third-party data sources you're working against? And if that solution has that offering, do they have a lot of customers also using the same connector you're using? So if you have like a very obscure CRM system and there's an ETL offering with that connector, make sure they have a lot of other customers using that connector as well. And this is because if that API changes for that offering, you want to know that your ETL provider will update their APIs to make sure nothing breaks. Another thing that's really important to think about is, does this ETL service have great support? So make sure you get references for the same connectors that you're using. And the pricing is very easy. Like the ETL provider will just tell you straight up how much it costs. When you build it yourself, the key thing to consider is this keyword provenance, which is, can I see from end to end where data is coming from, how is it being processed, and where are things breaking down or not working? And where do I also change the process? Where do I augment it? Where do I also remove a process that I don't like? So if you just have like a lot of cron scripts, obviously you don't have a lot of provenance. Like it's pretty much a black box. You have a lot of things kicking off, running, and if something breaks, it's hard to detect where it broke. If you want to change things, it's hard to understand which script to actually update. So keep in mind of the provenance. And then pricing for building things, typically when you start your ETL, the cost is going to be in labor. But eventually, like as your data gets larger and larger, it becomes a hardware cost. And finally, for all of our components in our data platform, whether it's the application, the database, or the ETL, there's 2 ways of thinking about how you're going to deploy resources for them or provisioning these resources. And that's just in time or just in case. So in the beginning, we usually go towards a just-in-case strategy because we don't know what the demand of our data platform will be. We don't know what the usage will be. So we're just going to provide a lot of resources. But in the future, like those costs become very prohibitive, and we're going to want to steer towards a just-in-time approach. This is a lot easier if you have like seasonal data usage. Like you have a lot of reports you need in the first or second day of the month. But sometimes like it's very like meeting oriented. Like there's going to be a meeting, and a lot of people are just going to open their laptops and use your data platform and just destroy the database. So that becomes very difficult to prepare for in a just-in-time case. And you can also like try to figure out a comfortable center between these 2 strategies that's reasonable for you guys to deploy. And next we have talking about fault tolerance.
Sweet. Thanks, Mike. I'm Zach Michael. I run our customer success engineering team here at Looker. And I'm going to handle the fault tolerance side of things. So I'll go through things like environments, promotion and testing, consistency. If anyone falls asleep, I'll throw a piece of paper at you because some of this can get dense. So this is what I call the stability to agility spectrum. I'm actually just going to click all the way through these so you can read them as I talk. But this is essentially what you want to think about when you're looking at your environments, right? There's a lot on here. And obviously from left to right, most stable to most agile, right? And when we talk stability, this is like high availability, that loaded term. When you talk agility, it's speed of development. It's how fast can you get data out? How fast can your users use and your developers develop? So on the way left of the stability spectrum is developer frameworks. So this is something like a staging and prod setup. This is where you will develop on staging, maybe even have a middle layer from testing, and then promote all the way to production, right? This is a process. You're going to have some environments based around it. Just after that is distributed resources. So this is like clustering, not to be mistaken for high availability. This is where you have multiple nodes that all sit within the application and power the application. So if one goes down, they don't all feel the pain. And then right in the middle is team isolation and open data policies. They're adverse of each other, right? So team isolation is just like if you have a finance team. That was just before me was about financial data. And it's if you want to keep your financial data in a different instance and only your finance team can see it, right? That keeps your data more segregated, but at the same time, it's a closed data policy. And so if you want to go more towards agility where your developers can make decisions and people can make data-driven decisions, you want things to be open, but that also then is a little bit of risk. So then you go to centralized resources. This is, you put yourself on a massive M5 8XL instance on Amazon Redshift with 64 cores and a whole bunch of mem. And it runs really fast, but to Mike's analogy earlier of a timeshare, you're not using all those resources. It'll prep you for your peak usage so that you never have to worry about it. And then the last thing is developer freedom. So this is the adverse of a developer framework. Everyone gets developer permissions. They work on the model. They build what they can. You train for it. You build infrastructure around it. It really depends on your business use case. But this is the way to think about it. There's no right answer for everyone. It's different per what your business platform is going to be for. So this is where Looker is. We're right in between. Oh, let me go back. There's supposed to be a gray box. It doesn't show up. Oh, it does over there. OK, so we're right in between developer framework and distributed resources. We run a clustered environment internally. We do segregate development a little bit, but it could be a lot better. So we're kind of happy right there. Daniel's shaking his head, which is good because he owns most of this. So I think we might be moving further to the left as we grow as well. So next thing, so promotion and testing, right? Hope this works as I want it to. So without promotion and testing, your entire org, anyone who uses your business platform is going to be a sad baby. They're going to cry to you, and they're going to be angry about things that break that they don't expect to break. And you're going to be like, sorry, I don't test that. Figure it out. But your org, with promotion and testing, anyone want to take a guess at what this is? It's a happy baby. You only hear giggles out of it, and that's about it. I'll get to this later, but we do a lot internally around promotion and testing with Looker. So if I go on, so things to think about testing, right? First thing, APIs. APIs are your friend. If you don't have someone in-house that knows APIs, can build applications using APIs, find someone. In the world today, there's a lot out there on the cloud that have core APIs that you could build applications that speak to each other. We do a lot of this in Looker. We have tons of products that we use, and integrating them all using APIs is beyond powerful. The other thing is automation, right? This seems like the no-brainer, but you'd be surprised. Maybe a lot of you in this room don't automate. We didn't used to automate. Super powerful because it's something that's predictable. It's a framework you can understand. And the fun side of it, for those of you that like to go into VI and read logs, you can find all the answers as to why anything breaks as long as it's logged, right? And so automation and APIs. So consistency. So there's 3 major parts of consistency. The first one's content, right? When you are looking at fault tolerance, you want to make sure everything is consistent. So this means in Looker, this is looks and dashboards, but wherever your tools are, whatever you're building, if it's reports, if it's folders of documents, whatever it is, you want to make sure that the user experience is retained and persisted across any system you have. I'll talk more about that in a little bit. The other thing is the model, right? So the model is the core definition of everything that is answered in your platform. If that is inconsistent across servers, across what your users use, now your conversations are inconsistent. You're going to get to arguing. You don't know what's going to happen. This is a super important one. And then the last, server. So if you're hosted by Looker, you don't even have to worry about this. If you're on-prem and you host yourself, this is super important because it's the backbone of the platform, right? If your server is not healthy, your platform's not going to be healthy. And the thing about a server and all of what happens inside of it, there's a lot of components and a lot of variability. So I would prefer that something like Ansible or some automation is used for deployment so that when you have multiple servers, if you're in high availability, if you have a cluster, and you're doing massive deployments and redeployments and backups, this is a key part that you want to make sure you have down. And then a shameless plug for those of you that it's really small text, so it can be a shameless plug. If you've never heard of Gazer, it's a tool that the customer success engineering team has built to help you port content across instances and manage content from the command line. So automation, a little bit more on automation, right? I don't want to beat this too hard, but make sure it's self-healing. If things break, make sure you have a way to fix them. Take backups, have some protocol around when something breaks, how you back it up, how you restore it, and make sure that's predictable and that everyone understands it who's going to be using it. Because the problem that we've seen is you have backups, but then someone goes and restores them improperly and you just make everything worse, right? So it's really important that you have a backup system and that you know how to use it. Deployment, predictable. That's all that needs to be, right? We talked a little bit about the server. You want to know when you're deploying, why you're deploying, what you're going to be deploying. You don't want someone to deploy a server and then a little bit later ask, why is this binary missing? Because I did it manually at 4 in the morning. That's not predictable, unless that's what you were hired to do. Provisioning. So this goes back to my spectrum, right? If you want a super agile environment, provision for that. Build a super strong server with a lot of CPUs and a lot of mem. If you don't, and you want, a ton of little servers all sitting under a load balancer, that's also okay, but know what you want and then provision for it. All right, so high availability, this loaded term. We kind of put it into 3 buckets. The first one's clustering. This is the most common. You have a lot of nodes. They all sit under a load balancer. Traffic is managed, and the application uses whichever one's most available. Looker has a clustering option. We're moving towards everybody being on a clustered setup that we host and making it easier for customers to cluster. I'll get into that. Containerization is another form of high availability, right? Removing the dependency on the server. This is where Looker's going in the next year or so in terms of our hosted infrastructure. We want to containerize. We want to be able to deploy through containers and remove that dependency. It's not the simplest, but it's worth the investment as we see it. And then this last one, auto-scaling. So Mike hit on this again with his timeshare analogy. Although if you could auto-scale your home, that'd be way sweeter, right? So for your server to be able to adjust based on your usage, you don't want to go spend $1,000 a week on a server if you're only using $10 of it, right? So figuring out auto-scaling, again, this goes back to my spectrum, however you want it to work. So that's it about fault tolerance, but what is Looker doing, right? So right now we have 200 integration tests internally, a lot of analyzing SVGs for content and visualizations. We use the API to do all of our data integrity, and then we actually use Gazer to port between instances. So this is our way of doing quote-unquote staging prod, which is also a loaded term, and also managing it through the command line. So future, right? I've said this a lot already. Automates containerized deployment. What does this do? It makes it so our customers who are on-prem can be cloud offering agnostic. If we have a container that just works, regardless of what cloud offering you're in, that's great. You can deploy anywhere with reliability, and then my Oprah quote for the day is high availability for everyone. So that's what I got. So Daniel, go.
Cool. Thanks, Zach. All right. So hi, everyone. My name's Daniel. I'm a data engineer at Looker. Prior to that, I was in professional services and helped some people in this room actually, with the jump starts and the implementation. So hi, all. All right. So Mike and Zach talked a little bit about scaling at the upper end of the stack. I'm going to take it back down to the bottom, the Looker application. All right. So one thing that my time in professional services taught me is every deployment is unique, and there's not one correct way to scale. So having said that, though, there are some common themes and pitfalls, and I'd actually like to go through what I believe is a pretty typical Looker lifecycle and point out a couple of these. All right. To do this, I want to introduce one kind of high-level concept, though, just to have as a framework for thinking about these problems. That is not the high-level concept, but it's relevant to the rest of the presentation, I promise. All right. Well, when I think about how I want to structure our BI team or the Looker application, it's usually in the form of this trade-off. I can have a really clean and accurate model, but it's going to come at the expense of an investment in time and, to what Zach was talking about, moving towards the stability end of that stability-agility spectrum. You could also be in the more agile end of that spectrum, but you're going to be sacrificing a little bit of cleanliness, a little bit of curation, and perhaps some accuracy. You could also just throw no resources at it and be over on that bottom left, and that's kind of where you are. All right, so at the end of the day, this is going to be a trade-off between how complex that your model is, how big your code base is, and how hard it is for users to navigate and find the things they need to do their jobs. So you want to balance those two competing kind of interests here. All right. So when you first get a Looker instance, typically you're going to connect some data sources to it and start modeling out relationships, some explorers, and all that. So this is the start of your BI tool. You're starting to encode business logic and LookML. For the end user, this is kind of like going through a grocery store and picking out different food items and creating your recipe on the fly. Okay, so the next step is creating reports, dashboards, really starting to work with your user base and develop content that they're going to use over and over. This will basically get you to a full BI tool, a full reporting platform. So this is like being at a restaurant, perhaps not a very good restaurant. There's limited content, but you can still pick through it. You're not cooking yourself. That's the big thing. You have some reports, some dashboards to go do. You can do your job without really having to dive in and make that food yourself. Okay, so the next step is developing workflows, developing tooling. So when I think about this, I think about writing to your favorite CRM, writing back to Salesforce from Looker using a data action, say. It's being able to send an email from your reporting platform to that hot lead that you really want to book an intro meeting with. It's enabling workflows within the platform without having to lead to other tools. So from what I've seen, there's a small gap to get to this. Most people are able to develop the BI tool pretty easily, but getting to operational workflows and tooling takes a little bit more resources. So we have a good partner network and professional services team that is always more than willing to help out, but we typically don't see this being too much of a problem for people. So this also happens to correspond with like the maximum amount of complexity you can have in your model. Now, the reason I say this is as you're developing all the content, you're modeling out your relationships, you're encoding business logic and LookML, your code base is just growing. Your content's growing as well. So this can make it more difficult for developers to develop new things, to keep dependencies straight, and even worse, it can make it difficult for end users to find the things they need to actually do their jobs. Here we go. So this operational workload here, or this operational tooling, I compare this to like a fine dining restaurant. It's just a better restaurant. I can do more things. Everything's just a little bit better here. All right. So we've also crossed the step here from BI tool into full data platform. We're now enabling more than just reporting. We're enabling people to actually do something with those results and take action on them. So to get to this next step here, where every business user feels like their experience is custom, they easily can find things they need to do their job. They have workflows that work for them and help them do what they need to do. To get to that spot, you have to cross what I call the chasm, the data buffet problem. So we talked a lot when Looker first became a company. One of our main value propositions, what we were saying, was we eliminate the data breadline. We can get you the data that you need. That would be more towards the agile end of that spectrum. So unfortunately, what that can put you in is a point where you have so much content that people have difficulty finding things they need to do. It's like being at a buffet, filling up on all the side dishes, mac and cheese and all that, and only to realize at the end of the day, dang it, they had crab legs and I didn't even have one of them. So you're filling up on stuff that is not really important. So how do you get over this? How do you go from that point where you have so much content, your model might be so bloated that people are having difficulty actually using it, your developers are having difficulty disentangling dependencies? Well, the easiest way, obviously, just don't ever get there. If you start a deployment with this in mind, then you can actually you can mitigate this chasm. So a move away from agile towards more stability, moving towards that clean, accurate. That's helped us quite a bit. Is putting more of a rigid development framework on the look-and-meld modeling. And then this is kind of obvious, but group users together. As your user base grows, a great way to curate content for them is with model sets and exposing only explorers that individual or group of people need. And a great way to keep yourself sane while you're doing this is just start using groups and put all the users into groups that make sense. Additionally, we also actually have a couple bits of tooling that we wrote to Zach's point, using the API, for instance, to see looks and dashboards that haven't been used in 90 days. We'll go ahead and just soft delete those. Looking at fields that aren't selected in explorers, that'll allow us to go in and hide those fields that just aren't being used and reduce the clutter in the Explorer. So those are a couple things that we do to get over this chasm. All right. So once you're over it, though, everything's great. You're a happy baby all the way. Let's see. All right. So I compare this step to having a personal chef. So a personal chef is not only going to make you the food that you like, they're also going to work with you to figure out things that you might not have tried before but would really enjoy. So this is where I see us going as a company, and where I think kind of like the ideal state to be in with the Looker application is. Just everything feels custom. It's a code base we can manage. It's a user base we can manage. The last bit of this is automating as many tasks as you can. When we're talking about scaling the user base, the code base up to hundreds, thousands of people, probably hundreds, thousands of view files, and bunches of explorers, as I'm sure some of you probably have. We certainly do. Automating as many tasks as you can is going to keep you sane. So what I think of when I think of this is, if I have a personal chef, someday maybe, they're not going to make the chicken stock and the roux every single time they cook a meal. They're probably going to make a big batch of that and be able to use it later and repurpose it and all that. So that's what automating can get you, is in the state where you're not making the entire meal every single time from the ground up from scratch.
Thanks, guys.